Welcome on this new course on data and localization. In this course, we will see how localization space introduces interesting dimensions to a dataset, and then we'll go through a series of explanations on the difficulties and the opportunities that localization brings to data. And we'll finish with two different point of views that I think broaden perspectives on localization. So the first thing is, what do we say when we discuss localization? Of course, obviously, it means that if you have a data point which is geo-localized, it means that we can put it on a map. We have an address or longitude and latitude, so we can position a data point somewhere. But we can just go a bit beyond that. If we have place, we also have distance. It means that we can measure to what extent two data points are neighbors from each other, or how long it would take to go from one place to another. Another thing that localization brings is movement. So it's not just about pinpointing on a map where data points are situated. It's also, it brings the opportunity to see how the position evolves in time. So movement, but also acceleration and speed. And finally, and I think very importantly, localization helps you understand how your data set is structured in terms of space. So this, let's take the analogy with a network. You can see how your data points connect with each other, right? And it can be based on similarity between these data points, or based on the co-occurrences of these data points, and the whole stuff about segmentation and finding clusters in a data set. But localization brings another dimension to the question, how are my data points relating to each other? You can see basically how they configure in space, whether they are all grouped in the same region, or maybe that you see, you can see the spread, how do they spread geographically. This is something that gives you a very important, important insights on the nature and the potential of your data set. So it's not just about putting things on a map, it's everything related to that. Place, distance, movement, and structure, configuration. So, for example, as an example to show how it has concrete consequences in terms of the value, the business, the monetary value you can derive from a localized data set, I take the example of Facebook, which in October 2014, they released a new way to advertise on their platform, on Facebook. If you're a small business, you can now choose to have a campaign running on Facebook that will just target the Facebook users living in an area close to your shop or your store. So it means that Facebook can basically monetize the fact that they know where we live. Basically, as a Facebook user, you probably describe the city you were living in, and maybe even your address. In this case, Facebook can sell this data to small businesses in the form of a campaign plan that basically makes it possible for the shops to target you because you live in a nearby area. The creepy thing is that it can also target users who do not live in the area, but that Facebook tracked, maybe through their mobile app, and Facebook knows that you were maybe walking by or driving by this shop. In this case, you will be included in the population targeted by the ad of this shop. Okay, so localization is really a powerful addition to a data set. Now, something that frequently happens when you discuss localization is that a way to increase your comprehension of a localized data set is simply to draw it on a map. So it's not just for because maps are beautiful or just easy to communicate with. It's actually because maps enhance our understanding. Instead of reading an Excel spreadsheet where you would see how, you would see just a list of data points and their longitude and latitude or address. I mean, of course, it's much easier to actually project these data points on a map, and at a glance, in a snap, you see you see where these points are located and how they spread and whether they are neighbors from each other, whether they move on the map, etc. So maps are business tools, really, to foster understanding and insights, to give you an aggregated view of the whole data set, but by zooming in you can also pinpoint very minute details, and it's also a very good way to aggregate different layers of your data set on the same place, in the same place, so that you can actually make comparisons and explore your data set, because using colors on the map or using symbols, you can aggregate many data sets on the same view. Just a reminder on maps, we could think that maps by nature are objective, because, you know, if you have just a longitude and a latitude where there is nothing to discuss, it has to be there. Well, actually not. There is a very nice episode from The West Wing, the TV series, that makes the point that the way you construct maps has strong social and cultural and political consequences. So I let you watch this episode.
Hi, I'm sorry.
Oh.
Sorry to be late.
Not a problem.
I'm CJ Craig.
Of course you are. I'm Dr. John Fallow. This is Dr. Cynthia Sales and Professor Donald Huke.
Huke?
Huke.
Okay, and you are the Organization of Cartographers for Social Equality.
Well, we're from the OCSE. We have many members.
How many?
4,300 dues-paying members.
What are the dues?
$20 a year for the newsletter.
Let's start.
Wait, I want to see this.
This is Josh Lyman.
Indeed you are.
Josh, this is Dr. Fallow, and
Hi.
who's Mary Men.
Yes.
Should we begin?
Yes. Plain and simple, we'd like President Bartlett to aggressively support legislation that would make it mandatory for every public school in America to teach geography using the Peters projection map instead of the traditional Mercator.
Give me $200 and it's done. Really?
No. Why are we changing maps?
Because, CJ, the Mercator projection has fostered European imperialist attitudes for centuries and created an ethnic bias against the Third World.
Really?
The German cartographer, Mercator, originally designed this map in 1569 as a navigational tool for European sailors.
The map enlarges areas at the poles to create straight lines of constant bearing or geographic direction.
So it makes it easier to cross an ocean.
But
Yes.
it distorts the relative size of nations and continents.
Are you saying the map is wrong?
Oh dear, yes. Look at Greenland.
Okay.
Now look at Africa.
Okay.
The two land masses appear to be roughly the same size.
Yes.
Would it blow your mind if I told you that Africa is in reality 14 times larger?
Yes?
Here we have Europe, drawn considerably larger than South America. When it's 6.9 million square miles, South America is almost double the size of Europe's 3.8 million.
Alaska appears 3 times as large as Mexico, when Mexico is larger by 0.1 million square miles.
Germany appears in the middle of the map when it's in the northernmost quarter of the Earth.
Wait. Relative size is one thing, but you're telling me that Germany isn't where we think it is?
Nothing's where you think it is.
Where is it?
I'm glad you asked. The Peters projection.
It has fidelity of axis.
Fidelity of position.
East-west lines are parallel and intersect north-south axes at right angles.
What the hell is that?
It's where you've been living this whole time. Should we continue?
Uh-huh.
So, you're probably wondering what all of this has to do with social equality.
No, I'm wondering where France really is.
Guys, we want to thank you very much for coming in.
Hang on, we're gonna finish this.
Okay.
What do maps have to do with social equality, you ask?
She asked.
Salvatore Natoli of the National Council for Social Studies argues, in our society, we unconsciously equate size with importance and even power.
I'm going to check in on Toby.
Go.
These guys find Brigadoon on that map. You'll call me, right?
Probably not.
Okay.
When third world countries are misrepresented, they're likely to be valued less. When Mercator maps exaggerate the importance of Western civilization, when the top of the map is given to the Northern Hemisphere and the bottom is given to the Southern, then people will tend to adopt top and bottom attitudes.
But wait, where else could you put the Northern Hemisphere but on the top?
On the bottom.
How?
Like this.
Yeah, but you can't do that.
Why not?
Because it's freaking me out.
Okay. In map, if you want to draw maps, I'm just going to give you a couple of starting points. So first, who is the leading creator of maps in at least in a web environment? Well, that's an agency called Stamen. They are based in San Francisco. It's always if you are in a large company, it's always a good idea to see whether you could hire them for a job, because you would just have the best in town. But if that's not a possibility, they produce a lot of open source tools, and they also advertise their creations. So checking their portfolio is a very good source of inspiration. Another tool or resource you could use is mapbox.com. It's a software as a service solution where basically they streamline the process of going from your dataset to a complete map that you can display on web pages or on mobile apps. So that can really save you some time. And finally, I'd like to mention OpenStreetMap. You could call it the open source version of Google Maps. It's a high quality map of the world that covers the whole world, but also all regions in much detail. And the particularity is that it's free to use even for commercial purposes, and it's curated by users just like you and me. So in some cases, it can be much more detailed than any other mapping solution. Okay, so that was for mapping. Now, I mean, it would suppose, I mean, if you would have data to project on a map, it would suppose that you have the data in your database in a suitable format. And this slide is to show you that it's actually not trivial to have your data in a geospatial format. Because if you just take the address of a customer, let's say, as the way to locate it, you have many issues with that. The first one might be that the address is not precise enough. Maybe because there is a mistake in the address, or maybe because it's incomplete. So address is something that is kind of noisy in a data set. Maybe you just have the city or a zip code, so you don't have always a precise location with an address. The second problem with an address is that it does not lend itself easily to interesting queries. If you are interested in the distance between two customers, that's not with the two single address that your database will be able to calculate the miles or the kilometers between these two points, because addresses don't reveal that. So you would need to store the information about localization in a format that would allow for calculations on distance, and you would also need to store that in a database system that has a query engine allowing for this kind of questions. That's a basic challenge. Then the second challenge is to export this data to a system, to a visualization system or an analytical tool, which is able to process geospatial data. And you don't have many tools able to do that. If you take Excel, Excel is not good at mapping or calculating distances or computing the surface of areas. What you need to have is what is called a GIS, a Geographical Information System, and that simply means a software specialized in dealing with geospatial data. You have two leaders on the market, which is ArcGIS, is the commercial closed source system, and QGIS, which is the equivalent but in an open source fashion, and it's free to use. You have to have a database. No, first you have to have your data in a proper format. You have to host it or store it in a database that allows for queries on location data. And finally, you need to have a software that allows you to manipulate, analyze, map, compute stuff on this localized data. On the database side, up to recently, up to 10 years ago, in the around 2005, traditional databases did not allow for storing data in a geospatial format, except for addresses, but I just mentioned address is not something that clean to use. But since then, proper solutions emerged. So Microsoft SQL Server is a database that allows you now to store information about location in a very complex and detailed way, and it also allows you to query these data points with complex combinations, such as measuring whether this customer is situated in this area. So that's kind of powerful if you can do that. And in parallel to these SQL traditional solutions, you have no SQL database that were created specifically to deal with localized databases. So CartoDB, for cartography database, is a solution that is exactly made for the purpose of storing geographical data and making queries on this data set, and also creating maps from it. So that's really a database making your life much easier to work with data, with localized data. Neo4j, which is a database focusing on storing networks, so entities and their relations, while Neo4j has also an extension that allows you to store and query specialized networks. And finally, I'd like to mention that JavaScript, which is a technology used to display web pages, like the most common technology you can find, they also developed data formats to actually display maps, and these data formats become increasingly popular, and we might find these data formats, so GeoJSON and TopoJSON, simply ways to write localized data points. These two formats, I would expect them to become more and more popular, and they might become in the future, they might become a standard way to represent localized data in databases. So keep an eye on this JavaScript data formats for localized data points. Okay, so that's it for the inner working and the details on localized data. Now I'd like to show you how localization by itself is nice, but when you actually combine it with other things, other powerful features of data, how it really becomes a winning combination. So when you take a data set which is localized and a data set where you have personalized data on the individuals of the data set, and if you have real-time treatment, well, you have a very nice combination. Because in this case, you can, in a marketing context, you can push notifications to these individuals in your data set, and the notifications, so maybe an offer or a suggestion or an invitation or whatever, these notifications that you send to your individuals will be incredibly relevant to them, because they will be sent specifically to these users, since we say you have a personalized data set, so it will meet their needs, their personal needs. If it's localized, it will meet their needs at the place where they are currently sitting. And if it's real time, if you have actually the exact position where they are at the particular moment, then you can also push a notification which is relevant to whatever they are doing at this space at this moment. So you have a much higher chance that the offer or anything that you push to these users is going to be relevant to them. And you will also avoid pushing stuff they would consider as spam. So you basically target your audience in a perfect way, I would say. This is not very frequently used. If you own a smartphone, you might just know by experience that not many apps do that. My guess is that apps will do that much more in the future, or at least they should do that if they have the necessary data. Okay, so localization is something extremely powerful. Now I'd like to finish this presentation with two different approaches on localization, two opposite actually takes on localization. The first one is speaking of territories. The basic argument is the following, that data, even if it's basically just zeros and ones, and data is something which is completely abstract. It's just code at the end. Data has very strong roots in local territories. So that's an argument made in a different context by Frédéric Martel, who is a French journalist and who worked on how global culture and global internet still had very strong regional or local declinations. So even if you have Amazon and Google, these kind of global giants, when you visit actually South America or the Middle East or China or Eastern Europe, you see that you have local versions of these global giants. It means that you don't have one single big internet. You have actually internets, plural. My argument is to say that that's the same with data. Even if data is something that you can count in terabytes and move around in digital format, it's still something that has still very strong local roots. If you just take data protection, the legal systems in different countries don't have the same rules for how data is allowed to be shared, how data about individuals are allowed to be stored, how data can travel from this country to another. So the data is actually localized a lot when you actually start using it. Using data in France won't be the same as using data in China or using data in Angola. This is the point I want to make. So the way data is used is also completely different. In Western countries, you would expect that each household would have a desktop computer with kind of a strong capability for data processing. In Africa, you would find that actually data is accessed through the internet a lot through mobile phones. It means that you can't do the same with the data in Africa or let's say in Europe. So data is of course something universal, but you have strong local context that constrain the way data can be used. And the last argument that I'd like to share with you is the opposite. And that's an argument made by the people who basically have a libertarian dream. They are sometimes called the cypherpunks. These geeks who are very strong at cryptography and who also have very strong libertarian values. So there is this book, This Machine Kills Secrets, that that tells the story of cypherpunks, and I would really encourage you to read it. Well, these people think that basically the internet and the internet and the data flowing on the internet is the best way to get rid of the local constraints from your government or the moral constraints that are legal constraints that are enforced in your country or your region. They think that if the data is properly encrypted in an anonymous and secure way, then it would allow any individual and organization all over the world to basically transact, cooperate, organize, vote, pay, build, work without the constraint of territories. It's simply enough that if two individuals want to work together or pay each other or co-work or co-create, then they could. What you just need for that is a system where their transactions on the internet are encrypted, anonymous, and secured from the intervention of governments such as the NSA spying. So that's a kind of dream that they pursue for 30 years now, but with technology evolving, you have actually realizations of this ideal that come to reality. So Bitcoin would be an example, BitTorrent would be another one to share files, and a new one is arriving in 2014, and that's called Ethereum, and Ethereum is a kind of toolkit to allow individuals to exchange data on the internet in a secure, encrypted, anonymous way. So Ethereum is both a currency, just like Bitcoin, but it's also a protocol to exchange data, files, and to create contracts as well. So I would encourage you to check on Ethereum, and it's very hard to understand what they do actually, but try to imagine how Ethereum is basically the opposite of a localized world. Well, I leave you on that. Thank you.